Hi everyone. So welcome to the presentation today on Azure Synapse Analytics for Cloud Professional. So this is the second part of a two-part series on Azure Synapse Analytics. In this session, we'll talk about how to use Synapse Analytics for data warehousing. Before we dive in, a quick bio about myself. So my name is Wilson Mock. I have over 15 years of experience in IT. I was a software developer for many years prior to moving into the data space. Currently, I'm working as a manager of data engineering at Avanade, where my focus is to help clients create, design, and implement data strategy to transform the organization decision making. Before that, I worked at CAE as a lead data architect. And before that, I was at Air Canada as a lead AI architect, where we created data and AI products to help optimize flight capacity and pricing model. If you would like to follow me, I can be found on LinkedIn, C# Corner, as well as GitHub at /Wilson-Mock. Great. So in this presentation, we expect the audience to have a fundamental knowledge of SQL. If you have any experience in Azure Data Factory, that will be a bonus as well. So as I mentioned earlier today, this session will cover a quick introduction of Azure Synapse Analytics, what is a data warehouse, what is data warehousing, and as well as to use mapping data flows in Synapse Analytics to create a data warehousing solution. This presentation has two demos. So after the first demo, we will have a 5 minutes quick Q&A session, followed by a longer Q&A session at the end of the presentation. All the code you see today will be available on my GitHub repo in a couple of days as well. Great. So Azure Synapse Analytics is a all-in-one suite solution for data exploration, data integration, and data warehousing. In data exploration, our focus is to bring data into Synapse so that we can evaluate the usefulness of the data. This can be done in a combination of SQL as well as in Spark, in Apache Spark. Synapse Analytics provide a serverless SQL and a serverless Spark capability to simplify the compute scaling as well as on-demand usage. The next item we have is the so for the data exploration piece, we covered it in the last sessions about how to conduct data exploration in Synapse Analytics. So if you're interested in this particular topic, I recommend you to watch the recording on the Dear Azure YouTube channel. So for the remaining two pieces is the data integration and then the data warehousing. So data integration is very similar to Azure Data Factory. It gives us the capability to build a data pipeline where we can extract the data from internal or external system. It loads the data into the data lake, and then as well as transform the data to the targeted system. And in our use case, we'll be focusing on the data warehouse itself. Now onto data warehousing, the goal is to store our data into the data warehouse, and in Synapse, this is called the dedicated SQL pool. This data warehouse is built for specifically for analytics as well as for reporting purposes. And to take advantage of the data warehouse, we will have to design a data model that makes the that gives us the capability to track the history of all the changes easier. So the two highlighted orange boxes, data integration and data warehousing, will be what we'll be focusing on this session today. So imagine a time when your boss asks you to create a report that shows the impact of our recent sales campaign. So this sounds like something we can do easily in SQL. So let's try it, right? So so after some investigation, you identify that there's two types of table in your sales database. There is the normal item, what we call the items table, and then there's also the archive table. So the archive table keep track of all the histories, while the in a case of this example, the stock items has the all the most recent records. So with these two information, we know we can union the data together, and then we will have a complete data set for our report. So you can also see that in our screenshot, the stock item ID is our primary key in the sales database. And look, when you look at the results, to no surprises, since there are some changes to the stock item, the result of the union item is the stock ID appear multiple times in the data set with different valid from and valid to dates. So the next step would be for us to just join this union data set with this union data set with various other tables that we need to do, that we need to produce a result, and we would be using the valid from and valid to date from the stock table union table to locate the correct stock ID to do the joint. So this query works great for what we need to do for this particular report. Now, your boss wants to look at the sales campaign from the customer behavior perspective. So what should we do? Now we really have two options. We produce a similar query as this, add the customer and customer archive information, union them again, and produce a very similar report. Well, so that method works great for one or two reports, but as your boss have additional requirements in the future, perhaps it's not a very scalable way of processing this data or to consume this data. It takes a lot of time for you to build this report on an ad hoc basis, as your boss asks you to. So we need to find a way to potentially automate this the best we could. So your boss can create a report however measure whatever components he wants to see, whether it's customer, whether if it's from the from the supplier perspective or from the sales perspective. So in order to achieve that, we can solve this problem through the use of a dimensional model. So a dimensional model reorganizes our data into two types of table. So we have a dim table and a fact table. We look at on the right hand side. So we will see the dimensional table are prefixed with the word dim. So dim customer is a dimensional table for customer, and a fact table is prefixed with a fact, which is in the middle of the star. Is our fact table. So in our case, we have fact transaction. So this data is arranged in the shape of a star shape, and there's a purpose for that. So in the before we dive into the particular reason for the star data, the shape of the star, let's talk a little bit more about the dimensional table. So the dimensional table stores the data that's responsible of who, what, where, when, and why. So as we mentioned a little bit earlier, we want to have a dimensional table for customers, for employee, for the stock items that we have. So when your boss want to do additional analysis, they can go ahead and select those business objects themselves or business entity themselves. Now we have so what do we store in the fact, in this case, the fact transaction? So the fact tables are usually used to store events on measure. So a simple example of that would be for us to store the profit or the number of sales that happens for the day, for each day that we have. Now the table is stored in a star shape with the fact table in the middle and the dim on each of the corner. It's because the dim and the fact are actually have relationship with each other, right? We want to know who make the sales of to a customer. We want to know which stock item we're using to sell to the customer, and when do we need to reorder, for example. So and that's why there's the star shape. It's basically the all the all the things that we can all the measurable items are in the fact. So all the dims are kind of connected to that fact. And of course, if you have multiple fact tables, you can use multiple dims to connect to them to generate different insights if required. So this data model is actually called a star schema, as you would expect, based on the star shape. And many people also call it the Kimball dimensional data model. It's more of the formal name. So this is not only the only data model that exists, but this is the most common one that is being used. And as well, for the presentation today, we will focus on bringing our sales data into the star schema. So let's dive a little deeper into how a star schema is designed. So we mentioned about quickly mentioned about the dimensional table and the fact table. So in the dimensional table, there are four important columns that gets created. So the first one is called surrogate key, or for short we call it SK. So this is the unique ID, the unique column identifier for the dimensional table. If you have a experience with relational database, this would be usually called the primary key. The next item we have on the right is called the natural key, or NK. So this is the source system's primary key. So if we have a table that, in a source system that tracks all the customer ID would be a natural key in this case. So the reason why we separate the primary key from the source system from the key that's within our dimensional table is because in the use cases where we need to track history, the natural key might be repeated, and you will be very inefficient to do a join when we don't have a unique ID to join with. So the next item we have is the ID hash. So this column contains the hash value of all of the natural keys that we have. So in the case where if your relational database model have a composite key, which means there are more than one column that makes up the primary key, then we will have two natural keys for this dimensional table, for example, and then the ID hash would be the combination of the two keys together. And finally, we'll have the data hash as well. So this is the column. This column stores the hash value of all the data values that for the data record. So this column is used to check if the source system has been updated or not, the records. It's just a shortcut for us to do comparisons instead of having to compare column by column, essentially. Okay. So as the data in the source system changes, as we mentioned quite a bit already, our dimensional table needs to be evolving as well. So some of the source system changes can create a new record, could be like updating a value on a record, or even adding a new column. So in dimensional model, we group the type of changes together, and we call them slow changing dimension, or SDC for short. So in the screen you see an example of that. That's the slow changing dimension 2, and we'll get to that as what that means. So there are a total of 7 different slow changing dimension. Today we're going to focus on the 3 most common type. The first one is slow changing dimension type 0, or SDC 0, and those are the table that doesn't change. And this is usually used for table that are to hold the date value, as well as for the dim time. Those are the very classic SDC 0 tables. For slow changing dimension 1, or SDC 1, those are where we overwrite this particular value. And finally, the SDC 2, the one you see on the screen, is where we would create a new row for every time a value is updated in the source system, and then we will also expire the old record as well. And because of that, we have to have 3 additional columns to support that activity. The first, the effective date and expiry date column, they work in pairs so that we know when this record was effective, and when does the new record or the new row, the new changes are now effective. And to simplify a little bit of that, we also have use an active or current flag, which allow us to quickly be able to identify which record is active at the moment. So next, we have the fact table. So similar to the dim table, a fact table also can contain a surrogate key. So the surrogate key acts as a primary key as well. And then there are also additional surrogate key, or SK columns that we will have. And those would be used to form the relationship with the dimensional table. So in this case, as an example, you will have a surrogate key for the fact table, and then you will have another column with a surrogate key linked back to the dimensional table, because there's a relationship between the two. Similar to how the concept of the foreign key is being used in the transactional database or relational database. Next, we have the ID hash. So the ID hash is slightly different than a dimensional table, because the fact table doesn't store the the ID hash stores the dimensional table's natural key, and not the hash of the surrogate key that gets created in the fact table. And finally, we have the data hash, which is the same usage as the dimensional table. It's a hash of all the facts values or measure that we use. Now, given that what we've been talking about, the source system do change, with many different scenarios, and as a result of that, we also have 3 different types of fact tables. So the first one is called periodic snapshot. So you can think of this table, it's to summarize the data based on a defined period. So a good common usage of that is if you have a monthly or quarterly reporting of your financials, you need to roll up all your data to monthly or quarterly results. The next one we have is accumulating snapshot. So that's very similar to SCD2, or the slow changing dimension 2. We will need to have effective date, expiry date, and active records, and so forth. And a common usage of that is how we track a shipping package, for example. As the package change from in transit stage to out to delivery, and then to deliver to your house, we want to track the timestamp of each one of those status. And for each status change, we also want to keep the records separate, so that we can have a clear idea of when each of the states has taken place, each of the status has taken place. And finally, the most simplest type of the fact is the transactional fact. So pretty much this is very similar to SDC1 or slow changing dimension one, where we just overwrite the existing value without creating a new record. So for today's demo, we will be looking at the transactional fact as well as SDC0 and as well as SDC2. And we'll talk more about that in the next slides here. Okay. So for our demo, we would have a much simplified star schema where we will have two-dimensional table and one fact table. So I'll kind of describe them from left to right here, starting with the dim table first. So the dim date is, like I mentioned, one of the base table that usually gets created when we create a dimensional data model or data warehouse, along with the dim time. And as I mentioned earlier, since this table, the value only gets appended to it, it doesn't change the value itself. As we add additional dates to this table, this table is categorized as slow changing dimension 0. And then we'll jump over to the dim stock item. So this table tracks our items in stock, and this is a SCD2 table, which means when the product changes, a separate row is going to be created for each of the changes. When the supplier decide to change the color on us, or how quickly the packaging or the shipment will get to us, we will track the record effectiveness separately. Okay. So with that, we'll jump over to our demo. So first, we'll jump over to our sales database, and we'll talk quickly about we'll quickly talk about some of the source data that we're having and how we would model that into our data model, or how we will organize our data into our data model. So first, similar to what you saw on the in the slides earlier, we can generate the invoice information by joining the invoice line and the invoice table together. So with this query, you can easily get the revenue that you would produce for each day, as well as how much profit you make for each day. And as you can see here, on September the 3rd, we sold over 20 different items, and for each of the items, the different financial impact to have into our system, into our company. So the next item we talked about on the screen before was the stock items. So the stock item, we're just gonna pick top 10 here. Shows all the stock item that we have. What is the color of the stock item? What size are they? How long does it take to get here from the from our supplier? Do we need to chill the package, right? It'd be important that if you are shipping some kind of perishable item, you might need to keep it chill, or something needs to be frozen. And also it tells you about the price, some suggested pricing information, and so forth, right? Details here. Lastly, there's also a valid from and a valid to date. So this will help us with finding the effective or expiry of the stock item as we move into the dimensional model. So the next table I have here is the stock items change table. So this table really is to emulate the result of the stock item and the stock item archive table. So in the case we can take a look at stock ID, item ID 77. So in here, we can see that the lead date time has changed from 7 days to the 14 days, starting in September 5th. So you would expect any sales you made on the stock will will take longer for the replenishment of the stock to come back, essentially. Okay. So this is just a shortcut for us so that we when we start building our data pipeline later on, we can simplify some of the work without doing the union. So there's about 20 changes that we made in this table, and we might come back to this and use one of the stock item ID as a case for us to check if our dimensional model is working, essentially. Okay. So there's about 10 different stock that has changed their the lead time, essentially, here. Okay, so so with that, now we have a better understanding of the of our source data or of our sales database. We're going to switch over to Synapse, and let's take a look. How do we design the dimensional model? Okay, so in here, this is my kind of playground environment. We have the Synapse workspace ready. You can click on open to open it up. For myself, I already have this kind of already opened up for our demo today. So what we're gonna do is we first need to create a dedicated SQL pool or a dedicated data warehouse, and we can do that from one or two places. We can come into here to the manage screen. Under the SQL pool, we can click on new, and this will allow us to create the dedicated SQL pool or the data warehouse. So I have done that already, and this data warehouse is already up and running. And when you're done with it, you can also pause it as well to ensure that you don't you can save some money there if you need to. Okay, so this data warehouse doesn't have to run 24/7 essentially. So the next thing we'll look at is will be the data warehouse the data warehouse tables that we're going to build, or the data model. So as we mentioned before, we're going to start with the dim date that we went over. As a reminder, this is SDC 0 or slow changing dimension 0, which means we mostly will just insert into this table. There shouldn't be any updating required. So in this table, we do have a SK date. So this is again acting as a primary key of this table. We have an NK date ID. So this is an integer representation of the date, and we'll get into what that looks like in the second demo. We will store the actual date itself, and then we will break down the dates into year, month, and day of month as well, and the quarter as well. So in doing so, once we it enables your boss to quickly able to summarize the data however he likes. So if he wants to do a quarterly reporting to see how the sales is going, all he has to do is filter based on the quarter. There will be no additional need for you to generate a quarterly report for your boss. So next thing to highlight here is the primary key that we mentioned for the SK date or the surrogate key. In data warehousing, we don't enforce primary key and any foreign key in that matter. So this is just created so that when we look at the schema or when we look at the column, we know there's this constraint, but it's not being enforced at all. Okay. With that, I'm going to create the schema as well with this. Okay, so it has ran. And then the second dim table we have here is the dim stock item. So similar to the dim date, we have a SK and an NK. Just a reminder, the NK is the source system's primary key. So some of the data columns we have is item description, size, lead date is chiller required, and so forth. We will be having, in this case, because this data is changing, we will be having the ID hash and the data hash columns. They're both the length of 256, as we'll be using hash 256 to generate those data. And lastly, since we need to create separate rows for each of the value change from the source system, we have the active flag, the effective date and expiry date here. Okay. Go ahead and run this. Okay, and then last but not least is the transactional fact. And as you can see here, this table is filled with decimals or integers, basically numbers that easily can be aggregated. That's usually that's the most common scenarios you'll run into in terms of for fact tables. We have three surrogate key. So we start with the SK transaction. As you can see, the name here is the same as the table name without the fact. That is to identify that this is the unique or primary key here. And as a result of that, the invoice date, the SK invoice date, and the SK stock item will be our foreign key. Again, we do not create the foreign key, and it's not actually supported in the dedicated SQL pool. But we'll, by keeping a good naming convention, we can easily find out where this this SK belongs to. Okay. Some of the data columns, that we have in addition to the decimals is the invoice ID. Just something we want to, your boss want to keep around to quickly able to see the invoice ID if he or she so desired. And then finally, since this is a transactional fact, the data can change, but you'll be changing in place with the same row instead of creating a new row. So we do need the hash values to identify if the incoming data is a new row or if it's an update on an existing record. Okay, so we will run this as well. Okay, so now we can navigate into the Synapse data tab, and this will show us all the table we just created. And this will be under workspace, SQL database. Here you see our data warehouse that we just created, or that we created earlier. Looks like there's a parsing here. Oh, looks like I had a selection there. Okay, you ran, so I can come into the table and do a quick refresh here. And we should see our three tables here. Now, those three tables are created without going through too deep of a configuration. In the data warehousing, sometimes you have to, if the data gets too big, you will have to optimize your table by defining hash columns for them, or to replicate the data set or so forth. So those advanced topic, we will leave it off. Okay. All right. So yeah. With that, we have our data model created in our data warehouse. With that, we'll jump into the first Q&A session.
Hey, welcome. Riyadh here. Just trying to understand. So you were talking about hash uh, partitioning the columns, right? So, so we haven't done that yet, right? Um,
Um,
are you? Go ahead.
yeah, we are. So yeah, so they are. So what we have defined so far is to define a column that stores the hash for the ID and for the data hash for the data itself. Um, we're not talking about optimizing the today we won't be covering the topic where we'll be optimizing the data warehousing table, like by applying replication set or hash key to the table itself. So that's a little bit of too advanced of a topic for this session.
Got it. Got it.
Yeah, but we will cover how to generate those hashes and how to build end-to-end data pipeline in the next demo.
Sure. And the tables that you are creating, this is on a dedicated SQL tool, correct?
Yep, that is correct.
And how exactly do they differ, dedicated and the serverless?
Yeah, so when you use a serverless SQL pool, um, you can only create an external data set. And that external data set, usually is backed by your data lake storage, where in the case of the dedicated, you can have both tables, internal tables that are stored in the SQL pool, as well as external tables that are stored in the data lake. If you are you interested to learn more about the serverless SQL pool? I recommend you to watch the first session of this topic of the Synapse Analytics. It's available um, on the Azure for All YouTube channel.
Sure. Yeah. Thank you. Just one last question here. Uh, so whenever we are storing any database or we have created tables, uh, the underlying storage, is it another data lake or Synapse has its own storage associated with it?
It's a great question. So in the dedicated, it is actually um, it's managed by Synapse, so it's internal to Synapse. So no, it's very similar to Azure SQL, right? You don't really see how the storage is managed. Where if you create an external table, your external table has to be backed by something, and usually that is your data lake or your data lake storage, essentially.
Got it. Thank you for your answers.
Yeah, no worries. And I saw a message here about the sharing the URL. I think the events team here will be able to share that with you, Silva, in a second here. I think they're try to got the link for you here. Okay. Any other questions? And please feel free to type your questions in throughout uh, the presentation or the demo. If you have a question, I'll try to catch them if while we're running some code, or I'll try to or we can address them at the end of the next Q&A session. Okay, right. So let's proceed to the second half of the presentation. So as you know, all the questions coming in, a minute ago, we're talking about how do we get the data into the data warehouse? Because now we have a data model, but we don't have the data in there. We only have it in our sales database. So to do this, we need to create a data pipeline in Synapse Analytics. So what is a data pipeline? A data pipeline is a way to funnel or extract the data from our source system. So that can be internal or external source system. We would load or store the data into our data lake storage. And then we will transform the data um, into the format that we or the structure that we want. In our case, will be the data model that we designed, and we will be using mapping data flows for that. Lastly, of course, after you transform the data, you have to write that out to the endpoint of the destination. In our case, this will be the data warehouse. And the reason why we want to do this is because in Synapse they provide a GUI to for us to develop this data pipeline in a low-code environment. So I want to expand a little more on the data transformation step here. So because there's a lot of different tools that we can use for data transformation. Sure, you guys heard of things like SSIS. You can use that. You can use Databricks, or also in Synapse Analytics they provide, or even in Azure Data Factory, it provides something called mapping data flow. So mapping data flow is a product that's built on top of Apache Spark to process our data. So this enables the data processing or the transformation to be done in memory, and it allows us to scale the workload by using a cluster or using multiple worker virtual machines. So lastly, as I cover a bit about this already, there's a user interface that allows us to do drag and drop code development without us developing the writing all the code for the data transformation. As I kind of mentioned that already, if you are familiar with Azure Data Factory, this process is very similar, and I'll highlight some of the differences when we go into the demo. If you want to learn more about the data pipeline in depth, I do have another presentation with Azure for All, specifically for Azure Data Factory, that covered more in depth of the data pipeline itself. So some of the items here we'll quickly talk about them, but we won't go as in depth as in that meeting. That's a good question. I just saw on the chat here. I actually haven't used the Power BI data flow, so I'm not too sure about that myself. But I do know in the one in Snap uses Apache Spark, which allow the scaling. I imagine is I don't know if the Power BI uses the Apache Spark as the engine that runs the data flow that they have. So unfortunately, I will not be able to answer that in the call today. Another question we have is about extracting data from the internal and external system. So you could be extracting data from the web if you want to get let's say weather data. So that would consider as an external system, right? Something that are not internal to your organizations or your own database, for example. An internal system is like a database that you have that you have a web app front end in front of it, for example. Okay. So we'll dive into the Synapse data integration demo here. So the 4 steps we'll take is we will extract the data from our sales database. So this will be an internal system that we're extracting from. We'll be storing the data into our data lake. Then we will transform the data using mapping data flow, and finally loading the data into the data warehouse. Okay. So let's jump over to Synapse here. Okay. So why DLTL versus ETL? That's a great question. So the benefit of the ELTL is actually because we're focusing on using Spark. So Spark is really good at actually having the data in a data lake environment, and able to store the data in a Parquet to read it. And that's why we're using we store the data, we extract the data before we run it. In some scenario, ETL might not be might not be really possible if the database doesn't keep track of history, and if you miss one of the extraction day, for example, you will lose some of the histories. So that's what we prefer to do, to extract the data first and then transform. In case something do go wrong, at least we have a copy of this data. Okay. So, all right, let's go into Synapse here. So in Synapse, first thing we need to do is to create what we call link service. So link service, essentially, it is the connection string, or it contains the connection information to our sales database. So, so in here, I just want to repeat that a little bit. So we go into the manage under link service. We can click new. And for our database, I know our database is an Azure SQL, so I'm going to go ahead and filter out or filter for the Azure SQL database. Just select that, and then I am going to call this the sample sales database, and I prefixed it with LS, and that stands for link service as a naming convention that I personally like to use. If you are able to access the, able to select your SQL Server database, you can go ahead and select it in here. For myself, I will have to enter this manually, as this user do not have the ability to see that information. So for this demo, I'll be using the SQL authentication. Of course, that is not the best practice. We should be using some kind of managed identity or some kind of managed identity or service principal to connect to it. But for the sake of the demo, we're just going to keep it simple and authenticate using SQL. And if you do end up needing to authenticate using the SQL authentication, it is important for you to at least the minimum store the password in the key vault, or you can connect, provide the connection string through a key vault as well. Just for demo purposes, we'll just keep it simple and connect with a plain password for now. So I click on the test connection here. Everything looks good. They're able to connect to the other server. So we're going to hit create on this here. So this is, if you're familiar with Azure Data Factory, this is slightly different, where when you create a link service, you will have to publish it. But in Synapse, it's automatically done for you. Another connection that I've created already is the connection to our dedicated SQL pool. So pretty much the same step as before, except that since our Synapse owns the dedicated data warehouse or the dedicated SQL pool, we can use something called a system assigned managed identity. Basically, it is the identity of the Synapse workspace itself. And since this workspace owns the database, you will automatically have access to that. Now, again, this is for demo purposes. It might not be the most ideal way of connecting, as it might have you might provide the link service with too much permission to your data warehouse. Okay. So while we do that, I'm just going to turn back on the debug because I need this in a second, and it takes a while to start up. Okay, so so the next thing for us to do is to actually create our data set. So a data set essentially is the tables we're going to extract from our sales database. So for that, I need to go into data. Okay, and then we will go into linked. And there's something called integration data set. So for that, I need to click on the plus sign. Under linked, select integration data set. Again, we know the data store, the database we're using is Azure SQL, so we'll go ahead and select that. And I like to keep my naming convention here. So this is, we will call it the data set for the sales database demo 2. And we would select the link service that we created earlier. Now, you can select and enter in the table name, but in our case, we're just going to check the edit button and leave this blank. And the reason for that is we want to leverage the capability of the parameter to simplify the creation of our data set. So we only need to create one generic data set, and we can use it on all the tables that we have. So I'll go ahead and click OK for that for now to bring this up. Now you can see again, the table is empty here. So we will go into the, in this case, we'll go into the parameter tab, and we will add in 2 parameters. So the first one, we will call it the schema, and the second one is the table name. And because I know the schema of all the data I have, it's all in demo 2, as we saw in SSMS a minute ago. So I'm just going to put in a deval value for that. Okay, so back onto the connection tab, our table selection here is still blank. We will check the edit again. In this case, we'll bring up the dynamic content. So the left-hand side here, this is the schema that we can just select. And then on the right-hand side, this is the table name that we can select. So with that, we'll publish all the changes. Okay, publish is done. So now we have this ready to go. Okay. So another, so I created another data set, prepared this data set for our presentation here. So this is the data lake data set that we have. In this case, I'm using the format Parquet, which is a format that is very compatible with Spark. It allows data compression at the column level, so that it enables Spark to read the data much faster and process them faster. So in here, as you can see, under the parameter, we have a directory as well. So we can generalize this this data set as well with the add dataset.directory parameter. Okay, oops. Just gonna cancel all of that. That's what we'll select, and we'll leave the file name blank. And Synapse Analytics will automatically generate a file name for us. So, all right, so this format is, yeah, so one thing I forgot to mention is the Parquet. It's an open source file format as well. So, if you end up not using Synapse at one point, you want to switch back to Databricks or to a different tool, even .NET, you can read the Parquet files without any issues there. Okay. All right, now with that, with the 2 data sets created, now we can go into our, we can develop a pipeline to copy the data into our data lake. So before we do that, since we're already at the screen of the link, so we're just going to take a look at our data lake structure very quickly. So I created a container called data, and we'll be extracting our data into the source data folder, and then under that is the sales database. So currently there's nothing inside here, and we would expect to have a couple of the a couple folders here with the Parquet files extracted in a little bit. Okay. So to do that, we need to jump back into the integrate icon, the little pipeline icon here. Okay, and we would maybe just take a look at the pipeline that I created here to kind of speed things up a bit. Again, a lot of this content has been covered prior in the Azure Data Factory demo. So please, if you want more in-depth explanation of some of the components or items that I'm selecting, please go ahead and have a look there. So, so back to the copy sales database pipeline. As we talked about earlier, we developed a generic data set for both the sales database and the and where we're writing the file to in our data lake. So so in this pipeline, I first defined two variables, and the two variables essentially contains all of the tables I want to extract. So in this case, I have 4 tables I want to extract: the invoices, the invoice line, the stock item, and then finally the stock item changes. This table contains kind of the changes of all the stock items that we want to process as part of the demo. And we also supply the data lake connection folder path into for this pipeline. Now, the reason why I'm using a for each activity, and you can find a for each activity under iteration and condition for each. This for each activity basically will loop through the sales tables, so all 4 tables here, and extract them into the location that we specify in the data lake location. So by clicking in the activities, we can see the actual copy activity that takes place. So in here, it should be no surprise that this will be the data set that we want to use. Okay, and then the table name, we can simply come in here. As you saw earlier, the variable has 4 items in there as an array. Once it comes into the for each loop, they become individual items. So there's a pre-built-in expression already provided for you, and that's add item essentially. So again, we're going to copy this from the demo2 schema onto the and the add item table. Okay. So for the sync, the directory I'm using essentially is the variable that we have, the location, and then we'll concatenate that with the table name essentially in this case. Okay. So one thing that we have is we can also manage how the for each really behave. So in this case, I want all of my copy to be running at the same time. Okay, so we don't have to wait for the copy activity to run each table at a time. You have the capability to just run them all at the same time. So we will do that right now. So I click the debug, start running. So you can see there's 4 tables like we mentioned, and then there's the for each that control all of them. So we'll give it a few minutes here for that to run. So let's take a look at the questions here. What is the version of Synapse? How to generate ARM template for this solution if version 2.0 or zip file be downloaded? So I will not be supplying how to deploy the Synapse. I deployed a pretty relatively simple Synapse. If you want to use the ARM template, you can generate it through, I believe there's an export capability, if I remember correctly. I haven't done that for a while. I think there is an export templates here if you want to do that. If not, you can always I think grab one of the templates from the Azure recommendation that they have there. Okay, but I will be supplying all the code that you see, including all the pipeline that we built today, but not setting up of the environment itself. Okay. All right, so quickly here. So as you can see, 3 of the copy data basically ran at the same time, and we're just waiting for the last one to be completed, and we just finished as well. So now we can come back into the data. Let's refresh this table. So we get all 4 objects here. They went pretty much all at the same time. So we'll just go into one of them. So the name that Synapse pipeline gave was basically the table, the schema name, table name dot parquet. If you're using this for incremental load to extract daily changes, that's what it means. Then you might need to append either a day in the file in the directory path, or you might want to change that as the name of the file. Okay, since this is all working, I'm going to publish this change as well. Great. Now we have the data in our data lake. In the data lake storage, the next thing we'll start creating is the dim day data flow. Okay, so I'm just going to close that out. To go to the dim day data flow, we'll go under develop. Okay, and then there's a plus sign up here, and we can select data flow. So, so this is the GUI that I mentioned about, the low-code GUI that allow you to create the data flow using Spark. So again, I like to keep a clean naming convention. So we'll start this pipeline with, or start this data flow with DF for data flow, and then we'll call it the dim day data flow essentially here. So the next thing we'll do is we'll add a source. So the data set that contains the invoice date information, that is the sales invoice itself. So with this, I'm going to just give a name for this block here to be called the source for the sales invoices. So this is where it's slightly different than data factory, where in the source type I can select inline source type, and what this allows me to do is to actually select the pre-created link service that's provided to us. So this link service is created as part of the Synapse when we created with the data lake itself. Okay. So next we'll go to the source option. And as I mentioned before, since we didn't provide the file name during the dataset extraction, we're going to be using a wildcard here. Okay. So we know that the file system or the container is going to be data, as we mentioned before, and then the wildcard path here that we have is the source data, sales DB, invoices, and then the Parquet extension here. Okay. So the next thing we'll do is go into the projection and run import schema. So what this will do is data flow or the Spark will go actually read the file and bring back the schema to us. Are the Parquet file not compressed? So that depends on your configuration. I think in our default configuration, it is by default compressed. I think it's LZO default compressed, but you don't have to compress it if you choose not to. Yeah, I think by default it does. The role of the Spark is pretty much the engine, similar to how database have a database engine, is the engine that reads the file, apply the changes or the transformation we want to do, and then also write the file out to our data warehouse. Okay, let's get back to the demo here. So for the projection here, for the projection here, it brings in all the columns. I think they are correct. We just want to double check to make sure the invoice date they bring in is actually a date and not a daytime, because it only comes in as a date. So, and sometimes we have to watch a little bit of that. We might have to override the schema, and we will show that in a different data set that we'll be creating in our data flow that we're creating in a minute. But just make sure you review carefully the different types, or sometimes you will get into trouble in transformations. Okay, so the next thing we can do is to go to the data preview and do a refresh, and that would essentially brings in some of the data into from our data lake itself. Okay, I also just went into the debug setting to increase the number of rows, as we might need to read in a little more data to do joins later on and so forth. Okay, so this is so this has the double check, take a look at the invoice date here. So this is the column, the invoice date. So there are a lot of invoices, that you make the sales on the same day. So so the next best thing to do for us here is to aggregate all the data together, because we try to generate a dim date. The dim date table is not going to have December 31st of 2021 multiple times. That will just be represented as one row. Okay, so to do that, we'll click on Add, and we'll select Aggregate. Okay, and we'll give this output name to be called Unique Date, as that's what we're looking for. So what are we going to group the column by? So we're going to group it by the invoice date, and the aggregation, or in the SQL term, this is the select statement at this point, the select part of the statement. We want to call this the input date, and then the expression that we want to use is first invoice date. So what does the first do? The first will pick the first value of the invoice of the different invoice date. Essentially, that's a unique for us in this case. Okay, and we can go ahead and check that by going into the data preview and click on refresh. So instead of seeing the multiple invoice date that you saw at the first source block, we should now start seeing unique values here. It looks to be that way. Okay. So the next thing we want to do is we just want to do some quick cleanup here. So what we will do in here, we will select and only keep the input date column. We will drop the invoice date column essentially. Okay, so just call this a select input date, and then we would go ahead and delete the other column. Okay, so now we only have one column coming out of this, and this is one thing you need to be quite mindful of when you're developing a data pipeline with Spark, is you try to reduce the amount of data that Spark has to crunch as much as possible. As if you don't, then you will, things will take longer and longer. Okay. So the next step here is we need to create another source of data. So this source will be coming from the data warehouse date table instead. And the purpose of this is to ensure that we need to start looking into how to generate the next surrogate key value for all the records here, right? Right now, we don't know if this records, all the value in this record here are already exist in the database or not. This is just what the file came in as, right? So maybe if the data already exists, we shouldn't be generating them. So with that, we will go again to the add source, and in this case, I will call this the source dim date. Again, we'll be using the inline source type. In this case, this is the Synapse data warehouse, the dedicated data warehouse. So we will use the data set type of Synapse Analytics. And the link service is the link first service that I showed you at the beginning of the second demo here. Okay. So under source option in here, you can click on refresh in this case, or you can just type it out. We know this is going to be demo, and then this table name is dim date, of course. Okay. We also want to enable staging in this case. What enable staging does is actually when the data get extracted from the database, it writes it into a temporary folder in the staging location, which is usually your data lake, and then the data gets loaded into memory. If your table gets really large, you'll be very difficult for data flow to process this data or to load it all into memory without going through the data lake, as it just, the performance is going to be not very good here. So we'll do the same thing as we did with the first source. We will do the import. Okay, and we see this. No, now we see that the date here is actually a timestamp instead of date. So we will go override this schema. We would give this into a date. Okay, then we override that that piece there. Okay. So now we'll go back to the main flow up here, and we will focus on now checking to see if the dates coming in here is exists already in the dim date. Okay, so just give me 1 second here. Yeah, so to do that, we will use the exist exist block. Okay, and what we're just going to call this find new. So the left is going to be the input date. The right is going to be the dim dates there. Okay, and we'll define the condition first, and then we'll come back to the existing type. So what we want to, how are those two data set have common? They are common by the date itself. So in this case, it's the input date on the select input date block, and on the right hand side, this is the dim date database table itself, and that would be the actual date. Okay. Now the next thing is we really want to we do not want to process any records that already exist in the dim date. So in this case, if there is a match, we really do not. We only want to keep the things that are not matching, that are new, essentially coming in from the invoice date itself. Okay. So the next item we need to do is to start deriving those new date columns that you guys saw earlier. So we're just going to copy and paste the name, call it the create date column, and then we have about, I think, 7 columns that we need to add. So I'm just going to quickly add a few down here. So we have something called the NK date ID, right? We have the date itself. We have year, month, day of month, and as well as quarter. So we have one too many. Okay, so for the NK date ID, what we want to do is take the date ID and actually generate a long or a integer representation of that. And what we do essentially is convert the input date into a string in the format of year, month, and date in all digits, and then convert that string back into a long. Okay. The date itself, to no surprise, this is going to be the input dates that we already have. And then for the year, there's a built-in function here already that takes care of that for the year. And we can do the same thing for month. And then I'm just gonna maybe copy and down for dates of month. Those are all built-in functions. And then for the last one, for the quarter, what quarter this date is under, we'll be using the month function, and it will divide it by 3, right? Every quarter is 3 months long, and it will do the ceiling of that. Okay, and we'll quickly do the data inspection here to make sure the conversion is it's working. Okay, so let's see here. Yeah, so that looks all correct. So the only thing that's missing really right now is the surrogate key or the SK. And before we can generate the SK, we need to go back to the database and really get the max SK value that exists in the database, so that we can generate a unique value for the rest of the new records here. So what we will do here is go back into the dim dates, click on the plus sign, and we want to do an aggregation. Okay, and I'm going to call it aggregation at max SK. We're not going to group by anything. So pretty much we are going to call the column max XK. And the expression we will use here is a if null statement. So what this translates to is you will you will grab the first item in your if null statement here, the first non-null item. So the first thing you would do is try to find the max of the SK date, and if this happens to return null, which means there's no row in your database, you will return 0 for you. So this is just a safeguard way to make sure you don't return null for your value there. Okay. So we will be using this max SK in 1 second. We will need to first create, go back to the top here and create the actual surrogate key. So this is so this surrogate key, it is not the final surrogate key. Is to actually essentially just generate the number from the starting value to each of the steps. So if you have 10 records, it will be the SK value they would assign is 1 to 10, and that's based on your starting value and your step value. So because this is not going to be the final SK column, I'm just going to call this as a temporary SK column, and it starts at 1, and then every record is +1 of that. Okay. So the next thing we need to do is to essentially join the max SK and the temporary SK together. Okay, and this is done through the use of a join, more specifically a cross joint. Okay, so in the cross joint, we're just going to call this the update SK. We have the temp, and then the right hand side we have the max SK, Now, because we're using a cross join, as you saw the error message come up, that I have to use a variable or a column from each of the stream. So in here, I'm going to I'm going to be using a formula here. Oops. And let's bring it up maybe in the builder, maybe a little bit easier. And that is the temp sk date. Is it the same as the max date? It doesn't really matter if this return true or false, because there's an or statement true. So everything is going to return true for this piece here. Let's see what that will allow. Okay. Having a little bit issue to bring up the having a little bit issue bringing up the custom conditions here. So maybe let's try this again. So we'll go temp sk equals to sk or see, they will be happy with that. Looks like they're happy with that. That's awesome. Okay, so I'm gonna, usually I would click on the data preview on this because we are cross joining, but looks like I'm running a little bit late in demo, so I'm just gonna keep going to the next step here. So the next item we need to do is to have the create the proper SK now, and as well as cleaning up all the extra columns that we have. So we're going to call this the adding the data warehouse dim columns. The first thing we will do is take the SK date and basically add the values of the two columns together. So that will be the temporary SK and then the date and then the max SK dates there. Yeah, I made a typo there. The K is uppercase. It's okay. All right. Okay, and then we would use a select again in this case to remove all the unwanted column that needs to be put into the data warehouse into our sink in a moment here. So as you see, once you do that, the list comes up. So what do we want? What don't we want? So we do not need an input date. We definitely do not need the temporary SK column and the mask SK column, as the SK date has already been created. So go ahead and delete those. And since I did quite a few of the blocks, I'm just really concerned about did I make any mistakes. So I'm just going to click on refresh here to make sure there are no issues that I would find in a bit here. So this looks all good. And we would use the final step to bring this data into the sink. So the sink is essentially our destination. Again, similar to the source we created, we'll be using the inline. We would be picking Synapse here and the link service to our data warehouse. Under settings, be demo2 and dim date as well. So for us, this just a reminder, this is SDC 0, which should be only insert only. So we're going to be allowing insert, again, allowing staging in case the data set gets really big. And that would be how you would create a dim date. So first, I will publish this pipeline. I don't want to lose any of my work. We did quite a bit of the work here. And then after we publish, we will jump into the test pipeline that I have already prepared. Okay, so this test pipeline is pretty straightforward. So pretty much is under move and transform. data flow. So we check this under the block. I put the description STC0, so we know this is essentially insert only. The data flow that we want to test, in this case, it is the dim date that we have. Oops. For testing, you want to leave your logging level as verbose. And I would like my staging folder to be just a sub-staging folder, just so I don't pollute the main folder there. And then I'm gonna do a validate, make sure everything is good, everything looks good, and I will hit debug. So this will take about 2 minutes to run. So I'm just gonna quickly look is the comments there. Is it a typo for the if nodes? That's a good question. It's actually there's two I's on the if nodes, and that spelling is correct. It's IIF node. Yeah, that is the spelling that they have. That the function is defined as. Ooh, we failed. What did we do wrong? Let's see here. Is the MS job fail sync? Insert nodes into the NK day ID. Very interesting. We have a mapping issue here. Let me see. Okay. Double check. Well, let's do a preview here. See, we will find the errors that we have. Did I perhaps made a typo on the name? We did the renaming. Okay, go check the error message one more time. That was correct. So I'm going to check the database. In this case, maybe I made a typo in the columns. Okay, date ID. No, that seems good. I wonder what happened there. Ooh. Hold on a second. How come the columns do not match? That's a little strange here. Let me just refresh this one more time. Trying to figure out what might be the difference here. So we do have the NKID here. Do have the NKID here. Why did this drop the column of NKID? That is very strange. Yeah, so we even have the NKID in here. That's showing me that this is in the output. So the only thing I can think of is something strange happened to the mapping. I'm just going to hit the import schema from the database and see what is going on here. Okay, column name look exactly the same, so I'm not sure why that didn't match properly, but that's okay. We'll refresh it one more time. Looks like now this is working. So we would debug this one more time. Okay, while we wait, maybe we'll jump into the other two data flows as well. So we're going to use, because of how complex the SCD2 pipeline is, I pre-built this this data flow so we can go over this, and then we'll come back and check on the dim dates in a second here. So as we mentioned, this is STC2, slow changing dimension 2, which also means that when there's a change of value, a new rows gets created. So we'll start with the first top 4 blocks here. We'll quickly step over them as they are pretty straightforward. Same as before, in the source, in this case, we're accessing the stock item, right? We still have the wildcard that we specify. We imported our schema through the projection. So the next thing we do is, like before, we select the columns that we want, and we rename some of the columns, right, from just the ID column into prefix it with a NK. So we know this is going to be a natural key for us down the road. We also renamed the valid from valid2 to an effective and new expiry date for us. And then the next thing we do is generate a hash. So since we only have one NK, this is pretty straightforward. Essentially, this is saying we are going to do a SHA-2 hash, 256 in length, of the string of the ID. The data hash is slightly more complicated, as not every single column is has a value in it. It can be null. So similar to what you see before, we're just doing the null check. If it's null, then we return an empty string, and we know that not every column would be empty. The chill column and the lead day column, I believe, is mandatory. But if you want to just blanket adding the if null check is possible as well. So I basically just concatenate or appending all the text together and then do the SHA 256 on this column. Okay. And lastly, we after we generate the hash, we go to just select the 4 columns that we will be using in a moment here. And only thing we're focusing on is the effective expiry date, and then the ID hash, and then the data hash that we have. Okay. Okay, so we're first going to jump down to the middle blocks here, and then we'll come back up as it will make more sense what we're trying to do here. So I'm going to skip over the max SK. You guys are familiar with what that does already in the first table we created. So in the second portion of this statement, in order to get the branch, all you do is click on the plus sign, hit new branch, and then a second branch will come up. And in here, what we really want to do is we want to find all the active records that are in the database. And if those records have been expired, we want to update the active flag and the expiry date of that record. Essentially, this is what this flow is doing. So first, we're going to find all the active records. So again, doing a give check just in case. If it's if the active flag is null, then it's going to return false. If this column should never be null, but just in case it's a check. And then the next thing we do here is the exist check. So similar to the other exist check, but this time we want to do the match. So anything that exists with the ID hash that are the same. So your record exists in the database and in the new data set. At the same time, your data doesn't match. So that means you have an updated column, updated value in this case. So with this information, we're able to reduce. So when we run this, nothing will happen because currently there's no data in the database. But if you do have data in the database, you will return basically all the records that has been updated that are in the database. So the next step here is to do the joint. And what this joint really does is it has two conditions. We want to find a record that has the same hash ID, and it has the original data values, because the file coming from above has already expired. So your valid today will be updated. So we need to find that match to find out what the expiry date is. For databases that doesn't have that, then you have to build in the logic here to figure out what the expiry date really is. As I mentioned before, this record will be, of course, no longer active. If it was active, and the expiry date is the new expiry date that came in. We will do some cleanup, and then we essentially mark all of this data that came in at the end here using the outer row. So that's under plus here, outer row as a row modifier. We want to mark them all as update only, basically, right? Anything that's in here needs to be updated. Okay, so that handles one of the scenario that we have, which is essentially focusing on updating any or expiring any records that we have. So one thing I skipped over that I think it'll be important to cover is this rule that you see here. This is not the generic fixed mapping. This is the rule-based mapping that I'm using, and we'll dive into that right here. So what this is really saying is any columns that is in this array, so the 4 columns that's in this array, I do not want this to be carried forward into my data sets. So the name is part of the Boolean expression that returns the column name that you're comparing with. So in this case, it's saying that if the name that pass in is any of those 4 items, I do not want it because there's a not in front of the in. So not in this list, then the double $sign. It's also a built-in feature that returns the current name that you went into the matching condition. Okay. Okay. So with that, there's the last scenario that we need to cover. That's when the record has been updated multiple times. So it's very possible when you processing the data for multiple days that the record is changed multiple times. So what we first do here is similar to what you have seen earlier in the dim day. We're going to do the match to see if to exclude everything that has the same ID and the same data hash, because that means nothing has been changed. So we don't need to do anything about that. And there's already an active record that's matching everything in here. We do the SK calculations. This is exactly the same as what we have seen before. But before we can continue on and marking all the records as active, is potentially some of the records is not active because of multiple updates, right? So in here, I did a branch. and then I did an aggregate. So what this aggregate really does is to take the hash ID, we group them by the hash ID, and then we did the max new effective date. So, pretty straightforward SQL there, selecting the max of the effective date essentially is what I'm doing here. I renamed the columns to have the active hash ID and the active effective ID. I'll use those columns to join back with the data set above. So basically, what this provided is, as long as the hash is matching, we will have a max effective effective date to use to compare with the record's new effective date, right? So we can compare the active effective date with the new effective dates to see which record is truly active. Okay, and that's pretty much what we did. What we do here in the derived column for the data warehouse table, we add the database SK with the generator SK. The record is only active if the new effective date is the same as the active effective date, and then basically just renaming column at this point. The ID hash, data hash, effective date, expiry date. Same thing as before, we do some extra cleanup, right? We know there's quite a bit of more columns than before that we need to clean up. So the using this type of expression instead of checking it and checking might be helpful if your schema continue to change if it does. Similar to below, where we're marking as updates. In this case, we're just marking it as insert. And again, you can go hit the plus sign, and that's outer row is the row modifier we use. We union all the changes together, and then in the sync, in this case, what we will do is we will select allow insert and allow update. And what they ask is, what is your key columns? So this is why it's so important to have an SK, right? So when we do this, the data flow can just check the primary key essentially and see if, and find a match immediately instead of having to do a whole bunch of comparisons and so forth. Okay, so that's the SCD2. But before we run the SCD2, I want to see if our pipeline ran successfully, and it did. So I'm pretty excited about that. So for now, I'm going to publish all of this changes that take place, and then I'm going to bring up my data warehouse query. Okay, and this is just queries that I've written ahead of time, so you guys don't have to sit here and see me writing SQL query one by one. So here you can see all of our data created. We should have over 200 dates, I believe. Yeah, so there's 200 dates. And then we're going to do a quick duplicate check here as well. So there's no duplicates. All right. So with that, I am going to just close off some of the item here. We will do the debug on the stock item that we just created. And we will quickly look at the last fact pipeline that the fact pipeline that we have, or the fact data flow that we have. So this looks a little more complex, but it's actually more straightforward than SCD2. And that's because this is a transactional fact. What that means is in this fact, we're only going to be update in place instead of creating a new row. So some of the logic is a little more straightforward that we will have. So as you can see in the fact tables, we require a lot of tables to be able to build the fact tables, because the fact table need to find use the NK to find the SK of a date, for example, or the stock item. So you will see a lot of input here, but don't be taken by that. Majority of the input here is really just finding the SK value, right? So as you see here, the select, we're only pulling out the date, which this is basically the NK. Well, this is the date itself, but there's an NK date I could cast to if I need to, and the SK itself. Stock item is probably a better example of that. We do have an NK that's a natural key of the database of the sales database, and then the SK. But in addition to that, we also pull in the effective expiry date because we could find an NK match, but we might choose the wrong one. One might be effective, one might be expired, right? So we want to make sure we bring in the dates as well, so that we're picking the right one essentially. Yeah, so I'll try to kind of go over this a little quickly. Oh, looks like okay. We'll come back to that. Okay, so in here, as you saw in the SQL query, this required both invoice line and invoices to happen. So that's why there's two extra sources here. The third data source here is the database fact transaction table. Again, here, very straightforward, right? We're just going to find the updated record with the exact same logic as you saw earlier, right? So we go to after we find the data with the data hash that are not matching, that means there's an update that taken place. We would match the ID hash, and then we would simply just use derived columns to update all of the column from the new data set that came in. We clean up, and then we mark all those records as updates. Okay. And then on the top here is the flow where we would insert the data into the data warehouse, all the new records. So to do that, we will select the column that we have. For us here, we have some additional calculations. So we want to find the total before tax, which you multiply the unit price by the quantity. Just additional, calculation that we want to pre-calculate for the fact table. We're going to use a lookup. So lookup is hitting the plus sign, the lookup entity here. So what this lookup entity does is essentially very similar to a join. So we match on the NK invoice ID here to pull in this data, and then this essentially merge the two data sets together. So from me here, I think it pulls in the NK. I believe it also pulls in the date, the NK invoice date here. We do some cleanup, right? Any columns that we want to rename, we're going to go ahead and get that done now. And then we're going to generate the hash like we have before. In this case, we'll come into the ID hash because now we need to generate the ID hash based on the NK value of the data that came in, and there's three of them, right? Where we have the invoice ID that we are using. There is the invoice date that map to the SK date, and then the stock ID that maps to the stock item table, the DIM table. At this point, we're going to find all the matches that does not have the ID hash does not match. So that means those are new records. We create our SKs like you saw before. We do a lookup to find the for the SK date, right? And then to convert the NK into the SK date. So you see here, that's why you're comparing the NK date with the, I just call it temporary date. but essentially the result of that is a join that brings in the SK date column into this data set. Just give it a second for this to process. Right, so you see the SK date here and the T date here. And we're doing the same thing essentially for the stock item. The stock item is slightly more complex as we need to find the correct effective expiry date pair for the invoice date or using the invoice date. And then, yeah, pretty much down here is the same as what you've seen before. The transaction date, setting the SK dates. Now we have them now, right? We renamed the SK dates to SK invoice dates in this case. And then we're keeping the invoice ID just so we can have a quick reference to the invoice ID if we need to ever do some data investigation, right? We would clean up some of the columns we don't need, mark them as insert, and then basically just execute them. So this is, although this looks more intimidating because of the number of data source we have, it is actually very similar to how you would implement STC1, of course, without all the lookups in between here. So with that, I will also run this fact pipeline, or the fact pipeline. And while this is running, since this testing ran successfully, we will run the query for the stock item, what we have here. Okay, so we do indeed have stock item inserted. That's good. And let's see how many there are. There are 227, which is perfect. I do not have a chance to run the code to bring in the stock item changes, but I will supply that into the Git repo, so you guys can run it if you choose to do so. And this is kind of the result that you would get. You will start with 227 records. After you bring in the changes, there will be 237. So that means there's 10. So there's 5 changes that took place that produce 5 expired records or 10 expired records, and yeah, produce 5 changes probably. Yeah, sorry about that. Now you can do it, and then this query will do the active check. Right now, you will return 227 as active, but when you pass this in, there will be 10 inactive and 227 active, as I just basically expired 10 of the records and added the 10 additional ones. Okay. So I will supply those as part of the Git repo as I think we're running slightly out of time here. So, okay, so this also ran, and I will just quickly check in the data warehouse to make sure the data is there. So the data is there, and the rest of the query down here, the next 3 query here is really to make sure that the logic is good for the fact table that is actually pulling in the correct association with the stock items, because when you run the extra data set to process, you will actually expire some of the records. So you want to make sure that because all the transaction took place before September 5th, if we run this query, you should expect to get the proper SK. But since I only have one SK ID with the item 86 in it, we cannot really show that in this current live demo here. But I will kind of wrap this up really quickly here with the last query that we have, and that essentially is to generate a very similar data set that we have for as what you saw in the SQL earlier. Gonna quickly do up a chart that shows that our analysis here. So in the data set, we actually ran 2 sales. The 2 sales took place in April and May for one sales period, and then we did another sales period between July and August. So as you can see, the sales didn't really. There's a spike in April and August, but really the sales didn't bring in overall any additional revenue. The revenue overall, if we average out the numbers, actually relatively flat. So we do not think the sales is worth doing, at least not at the current sales range that we have. And finally, the one last item is how do we put all of this together, right? Because in a production environment or in a processing environment, you don't want to run each of the data flow one by one. So what we needed to do is to relate the data flows together, basically all 3 entities, drag them in from the 3 testing data flow that I built. And your fact table is always going to be run second. You're probably going to run through all the dim tables first. So that way, when you look up for the SK exists in the other in the dim tables, basically. Okay. So I kind of gone a little bit over time there. We'll do a quick summary here, and then we'll jump back into the last Q&A here. So just to summarize, we designed a dimensional model here with a star schema for a data warehouse. We learned about different type of slow changing dimension. More importantly, the SCD1, SCD0, and SCD2, and the different fact tables that we have, the transactional, the periodic snapshot, and the accumulating snapshot, which produced a new role similar to SCD2 inside Synapse Analytics. And we learned that Synapse Analytics allow us to create low-code data pipelines. We can do that through drag and drop, and we have 4 steps to build our data pipeline. We extract the data, we load them into a data lake, we transform them using mapping data flow with Spark, and then we loaded the data finally into the data warehouse. The reason why we use mapping data flow is because it's based on Spark, and it allows us to process our data across multiple VMs or a cluster of VMs. Finally, we also loaded data in the data warehouse. The data warehouse that we're using is the dedicated SQL pool. That's what they're called in Synapse Analytics. And finally, all the code that you saw today and a little bit of the code that you get a chance to run will be available in GitHub. Here's the link. Will be available in about a week from today. Okay. Any questions? That was a long demo session here, so. Okay. We'll give it maybe another minute or two, see if anyone else have any questions. Okay, if there's no more questions, I want to thank you everyone for coming.